Okay, the final stats question. Annie and Ben play a game by throwing a pair of dice in turn. Annie's dice total 9 and she wins the game. But if Ben throws a score of 7, then he wins the game. Anya throws first. Okay, so before we build this repetitive tree diagram, the first thing we need to do is figure out what the probability is when you throw two dice of getting a total of 9 and a total of 7, which is the sort of question you would have had at GCSE. So if you think that you've got two dice, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and you're going to add the pair together, 2, 3, 4, 5, 6, 7, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. So you've got 36 possible outcomes. So Annie is going to throw 9. So those are Anya's possible outcomes. So probability, and probability of achieving a 9 will be 1, 2, 3, 4 out of 36, which is a 9th. If we look at Ben's 7, we can see there are more ways to score a 7. So the probability of a 7 is 1, 2, 3, 4, 5, 6 out of 36, which is 1/6. So chances of Ben winning is higher than the chances of Anya winning. But Anya's going to go first. So for the first throw, Anya is either going to get a 9, and if she does, she wins, or she's not going to get a 9. Chances of her getting a 9 is a 9th. Chances of her not getting a 9 is 8/9. Then Ben's going to throw. And Ben, to win, is going to throw a 7, which is a 6th, or not a 7, which is 5/6. And then it would repeat. So we go back to Anya, and then back to Ben, and then back to Anya, and so on. What's the probability that Ben wins on his first throw? So for Ben to win on first, it's going to be probability of it not being a 9 and the probability of it being a 7, which will be 8/9 times 1/6. So 8/9 times 1/6. Why did I just hit cos? 8/9 1/6 4/27. So that's the chances of him winning on the first. Now if he wins on the second, then that means Anya's going to lose, which is 8/9, and Ben is going to lose, which is 5/6, and Anya's going to lose her second throw, but then Ben's going to win. So you've got lose, lose, her again, lose, him win. So that is going to be Let's simplify it, it'll help us see the pattern. So we've got 2 lots of 8/9 and a 5/6 to the power 1 and a 1/6. So eight ninths squared times 5/6 times 1/6. So 80 over 729s. Show that the probability that Ben wins the game is 4 over 7. Now this game could go on forever. It's a game of chance, it's unlikely to, but there's nothing stopping that just repeating forever. So we're going to end up with a geometric series which we're going to sum to infinity. But let's just build the geometric series first of all so you can see what's happening. So what we've got, if he wins on the first, it'll be 8 over 9 times 1 over 6. The second, it's this 8 over 9 squared times 5/6 to the 1/6. Now we could have had the 5/6 there to the power of 0. That might have helped see the pattern. So the next one, without working through it, I'm going to have 8/9 cubed, 5/6 squared, 1/6. And that will repeat forever. So the first term is the 8/9 times 1/6. The common ratio will be that divided by that. And the sum to infinity is a over 1 minus r, where a is the 8/9 times 1/6, which we know is 4/27. And the ratio, well, if I divide that term by that term, the 1/6 will cancel, the 8/9 will cancel with one of those, and the 5/6 won't cancel because that's just 1. So you end up with a common ratio of 8/9 times 5/6. So the probability is going to be a over 1 minus 8/9 times 5/6. So on my calculator, fraction. In the top fraction, 4 over 27 over 1 minus, open bracket, fraction, 8 over 9 times 5 over 6. Oops. Close bracket, and hopefully that'll give us 4/7. Whew. Okay, so there's an overlap there with your AS Pure when you're doing arithmetic and geometric progressions, and that has come up as a past paper. I've just modified the context of the question there, so it's worth spotting that where you've got this game of chance which is alternating between one winner and another, that's how it builds up.